Welcome back to another explainer. If you're a focused learner trying to wrap your head around exactly how data center management is evolving right now, well, you are in the right place. Today, we're unpacking a massive shift in the tech landscape. We're going to look at how traditional server orchestration is essentially being forced to adapt to the incredible high-density environments that modern AI requires. It's the question keeping infrastructure architects awake at night, right? Is your management software actually ready for AI workloads? Because the reality is, managing a standard rack of enterprise servers is a completely different ballgame than orchestrating the extreme demands of modern AI clusters. We're talking high-density power and incredibly complex liquid cooling infrastructures. The tools that got us here, well, they might not be the tools that get us to the next frontier. Okay, let's dive into this. We're unpacking a really comprehensive competitor battle card today to see exactly how the major players stack up. Our analysis directly compares Supermicro SuperCloud Composer, or SCC, against Dell OpenManage Enterprise, HP OneView, and Cisco Intersight. To make sense of this massive data set, we're just going to break it down into 5 logical areas. 1. The infrastructure management landscape. 2. Core observability and monitoring. 3. High-density power and cooling. 4. AI and GPU operations. And finally, deployment, security, and scalability. Okay, let's kick things off with part 1, the infrastructure management landscape, and defining the core focus. Before we really get into the weeds here, we need to establish the baseline focus of these platforms, and the data shows a pretty fascinating contrast in their underlying philosophies. On one end of the spectrum, you have Supermicro SCC explicitly targeting rack-scale infrastructure observability, which is specifically tuned for AI and data center environments. Contrast that with Cisco Intersight, which is deeply rooted in policy-driven UCS operations, automation, and hybrid cloud management. So right out of the gate, they're solving different primary problems. When it comes down to the actual managed devices, we see a really clear division. Dell and HPE offer highly advanced, centralized management for their traditional servers, chassis, and storage systems. But Supermicro uniquely broadens this definition of a managed device to cover the entire AI rack, and that includes liquid cooling infrastructure and cooling distribution units, or CDUs. You know, assets that traditionally just sat completely outside the scope of server orchestration software. Moving right along to part 2, core observability and monitoring, the traditional foundation. So this is the traditional foundation of literally any data center tool. All 4 vendors excel at standard server monitoring, which, let's be honest, is exactly what you'd expect. But take a look at the firmware lifecycle management. While HPE and Cisco have standard or kind of limited profiles for their specific servers and fabrics, Supermicro actually achieves an advanced rating here. Why? Because its firmware lifecycle management extends way beyond just the server chassis. It specifically reaches right into GPU components, power distribution units, and those CDUs we just mentioned. Now, for part 3, high-density power and cooling, and really the thermal challenge. This addresses arguably the most critical operational challenge of our era. AI racks run ridiculously hot, and air cooling alone simply cannot keep up with the latest generation of accelerators. But before we analyze how they handle it, let's just quickly define PUE, or power usage effectiveness. It's the gold standard metric for measuring data center energy efficiency, comparing the total facility power against what the IT equipment actually uses. To calculate this accurately, your software obviously needs broad visibility into everything drawing power. Now, what's really interesting about this data is the stark contrast in cooling management. Impartially speaking, Dell offers standard cooling infrastructure support, while HPE and Cisco offer limited, primarily server or chassis-level thermal visibility. Supermicro, on the other hand, scores an advanced rating. It provides really strong support for high-density cooling visibility, and that includes direct-to-chip liquid cooling telemetry, thermal data, and even leak-related event detection. We're looking at these thermal telemetry facts to prove a point. In a high-density environment, your standard server fan speed metrics just don't cut it anymore. Summarizing the power and cooling contrast objectively, we see Supermicro and Dell leading the pack with strong telemetry capabilities. AI workloads require management tools that can actually talk to the power distribution units and the cooling distribution units. I mean, think about it. If your software can't see the thermal output and pump pressure of your liquid cooling loop, you aren't really managing the AI rack at all. Let's pivot to part 4, AI and GPU operations, the next frontier. The GPU is absolutely the engine of the modern data center. So how deeply can these platforms actually see into it? while Dell scores a strong rating here with great telemetry for its PowerEdge GPU platforms. Supermicro achieves an advanced rating through its use of Prometheus-compatible exporters and validated in-band telemetry sources like NVIDIA DCGM and AMD ROCm. HPE and Cisco offer more standard or limited views here, often relying on other cluster management tools to get that richer GPU data. And this brilliantly illustrates the shift in perspective required today. It's one thing to provision an OS onto a bare metal server, which Dell and Cisco do exceptionally well, by the way. But it's entirely another to manage a physically aware environment. Managing a single GPU server is fundamentally different from managing an entire AI-aware data hall. Just look at rack and data hall awareness. Dell provides strong physical hierarchy mapping across the data center, room, and aisle. HPE and Cisco maintain standard visualization for their specific infrastructure. But Supermicro provides a strong pod, rack, and node topology that actually ties device placement directly to power and cooling context, so you know exactly where the heat is being generated in the physical room. Finally, Part 5, Deployment, Security, and Scalability, Securing the Operations. It really doesn't matter how great a tool is if it can't be deployed securely and scaled reliably in a massive enterprise environment. One of the strictest security requirements for high-tier data centers and government installations is the ability to run air-gapped, meaning the management platform can be deployed, operated, and fully updated in a totally isolated environment with absolutely zero internet access. Fortunately, the data shows all 4 vendors support offline or air-gapped deployments. Beyond that, Cisco leads in SaaS and cloud-connected deployment models. Interestingly, though, while everyone supports deployment as a virtual appliance, Supermicro uniquely supports customer-hosted bare metal deployments for its management software. When evaluating enterprise readiness, all 4 platforms offer really strong security postures with comprehensive audit logs, role-based access controls, and SSO integration. But the real differentiator at the enterprise level comes down to scalability and resilience. So the crucial point is how these systems handle immense operational workloads. Dell and Cisco publish high scalability up to 8,000 managed devices for traditional hardware management. However, AI rack scale telemetry produces a massive volume of data. To handle this, Supermicro supports high availability for its Kubernetes control plane when deployed with multiple master nodes. It's specifically engineered to process those super heavy AI telemetry loads without a single point of failure. Stepping back to look at the entire analysis, the overarching thematic arc is absolutely undeniable. The very definition of data center infrastructure has fundamentally expanded. It's no longer just about centralized server chassis management. It has evolved into whole rack, thermal-aware, and GPU-centric orchestration. Power and liquid cooling are now first-class citizens in the management stack. Which leaves us with one final thought to consider. Take a look at the tools you rely on every day. Ask yourself, is your infrastructure management stuck at the server level, or is it actually ready for the AI rack scale future? Thank you so much for joining me for this explainer. Keep learning, keep evaluating, and we'll see you next time.